Hello students, last time we discussed the Cartesian coordinate system. What we are going to discuss today is a continuation, okay? And in order to do that, let me start with an everyday life experience. Suppose I'm about to rent a studio apartment and the rent for that apartment is $500. At the same time, I also have to come up with a deposit of $1,000. Furthermore, I'm planning to stay in that apartment for at least 4 months. So I want to know beforehand what my expenses are going to be. In other words, my rental history in that apartment. So let me start with what we know, or with what I know. Rent, 5. Deposit, 1,000. Okay? Now let me draw a table that probably gives me some clarity about my expense. So I'm going to write month here. I'm going to do expense and total expense. I'm going to write 0, 1, 2, 3, 4. Now, look at the number 0. Month 0 is not the month that I'm moving in. It is the month that I'm putting a deposit for my rent to secure the apartment. So, my expense for that month is $1,000. Therefore, my total expense is $1,000. Now, at month 1, if the month 1 is the month that I'm moving to, so meaning what? I have to come up with $500. So the expense for that month is $500, but my total expense now rises to $1,500. I'm going to do the same thing for month 2. Month 2, I have to come up $500, the expense for that month, and then my total expense is $2,000. At month 3, again, another $500 expense, and then now my total expense moves to $2,500. At month 4, another expense of $500, so my total expense is $3,000. In other words, if I'm planning to stay for at least 4 months, I better come up with $3,000. Now, there is also another way of describing this event, which is the Cartesian coordinate system. So I'm gonna draw this. Okay. So now let's label the two lines. Let the horizontal line represent the number of months that I'm spending in my apartment. In this case, 4 months. And let the vertical line represent my total expense. Okay? Now, if you remember when we were discussing the Cartesian coordinate system, we discussed about this particular point also. Okay? So this is the origin, and we call it 0. Okay? And let us say that 0 represents month 0. So my expense at month 0, my total expense. Okay, my total expense at month 0 is $1,000. So I'm going to put 1,000. Since I don't have a graphing whiteboard. I'm gonna cheat. So I'm gonna go backwards. So I'm gonna draw me a straight line. And bear with me, I'm gonna draw 4 rectangular pieces. So, okay. And this will help me label somehow correctly the month. So this is month 0, since the horizontal line represents the month. I'm going to write 1, 2, 3, and 4. Right? And these are the points that represent my total expense as the months go by. So at month 0, my total expense is $1,000. At month 1, my total expense is $1,500. By month 2, my total expense will go to $2,000, $2,500, and then $3,000. This is a graphical description of my rental, right? So now, I want you to focus on this particular point because they give us a key to the concept that we are discussing today. So I don't need this. Now, how do we, now we are going to ask ourselves, how do we get from this point to this point? Okay? Now, if I move from month 0 to month 1, so I can draw a horizontal line, right? Month 0, and then if I move from 1000 to 1500, I'm moving up, right? How much time has elapsed between month 0 and month 1? 1 month. So this particular line represents the difference between month 1 and month 0. Simultaneously, what has happened is a change in my total expense. So what happened between my total expense at month 0 and at month 1? There is a $500 difference. So this represents $500. Let me do the same thing between month 1 and month 2. Between month 1 and month 2, 1 month has elapsed. So I'm going to put 2. And at the same time, my total expense has increased from 1500 to 2000, which is what? A $500. And the same thing also goes between month 2 and month 3. 1 and 500. The same also between 1 and 500. What is this constant number 500? It's my rent money. It's the expense per month. So meaning what? I can write it as a proportion. $500 per month. And this number remains constant as long as I stay in that apartment or as long as the landlord does not increase or change the rent money. It stays the same. It stays constant. 500, 500, 500. While the others change. While time changes, the ratio does not change. 500 per month. 500 per month. Okay? I want you to take that into consideration. Okay? Now, Let me take you back to the table and see how we got $500 per month. How these $500 are found. Look now, what is the difference of my total expense between month 1 and month 0? At month 1, I had my expense is 1,500. At month 0, my expense was 1,000. Since 1,500, my total expense 1,500 was at month 1, so I'm going to do 1 minus 0, and 1,500 minus 1,000 gives me 500 over 1. Let me do one example because it's going to stay the same. So between now month 2 and month 1, my expense would be 2,000 minus 1,500, and the 2,000 is my month 2, 2 minus 1, which is again 500 over 1. Let me do another one. From 2,500 to 2,000, meaning what? From month 3, my total expense from month 3 is 2,000, and the 2,500 is month 3 minus 2, and then I'm going to get the same 500 over 1. Meaning what? My expense, the expense that I incur every month. Guess what? That is what we call in mathematics our rate of change, or in other words, our slope. The slope for my rental history is $500 a month. It's a constant number that doesn't change. Okay? So, now we are ready to write a formula, not just only for my rental history, but for other everyday life experiences. That's the beauty of mathematics. Now, so let me just take out month and replace it by x. It's just only a symbol. Okay? So I'm going to write x. And my total expense, instead of writing total expense, let me put it. Meaning what? This horizontal line represents x, which is my month, and my total expense represents y. And let's see how we can actually get the slope using the variables x and y. Now, we have said at, at month 1, my total expense is 1,500. Oh, before I do that, my apologies. Let me also label, instead of 0, I can do x0. Okay? And my 1 becomes x1, x2, x3, and x4. This is going to be a little bit messy. My board is so small. Okay. And then my y. Instead of saying 1,000, I can say y0. Why not? My 1,500 total expense becomes my y1, y2, y3, and y4. Okay? Now, remember, we got the slope, or the $500 per month, okay, constant, by doing what? If I subtract 1,000 from 1,500, meaning what? My total expense at month 1 minus my total expense at month 0 with the corresponding months, meaning what? My total expense at month 1, my 1500 corresponds to month 1, so meaning that 1 minus 0. Okay, so meaning what? 1500 minus 1000 gives me 500, and 1 minus 0 gives me 1, which is my slope, okay, or my rate of change. Now, instead of putting 1500, I can replace it by my new symbol, which is y1. So I can put y1 instead of 1500. My 1000, instead of writing my 1000, I can put y0. My 1, instead of writing my 1, I can write x1. And instead of writing x0, I can write x0, right? And then instead of writing 500 over 1, now we know that this is what a slope is. It is a slope. But in mathematics, we use the symbol or the letter F. And guess what? We have found the formula to find a slope. The slope is the difference, the ratio of difference between two values of y and the corresponding two values of x. Furthermore, how did we get $500? This is what? It's a rise. The graph is rising by what? By $500. By 500 units. By 500 units. It's going up. So meaning what? $500 describes the rise of the graph. At the same time, how did we get 1? By moving towards this to horizontally, by moving horizontally. So that means what? It is run. Rise over run is also another description of the slope. Okay? So just to wrap this up, I'm just going to write some definitions that also highlights our discussion. Okay? The slope is a constant number. Right? A constant number that we get by dividing the difference between two points of y, because we have already called this y and this one x, okay, between 2 points of y with the difference between two corresponding points of x, right? So this ends our preliminary discussion of the slope. There is a lot to talk about the slope, and in the coming steps, that's what we are going to do. And for now, I'm going to leave you with this, and you have a good day.